So in this video, I'm going to go over a few questions in a textbook that you may see related to quadratics. So in the previous two videos, I've gone over basically the fundamentals of quadratics. Now there's more to it. Obviously, if you go through a textbook or if you go through a lecture of some sort, you'll probably see that there are a few things I missed, but went over the fundamentals. And today I'm just going to go over 2 or 3 questions to help out and just emphasize the importance of the things we went over in the previous videos. So the first question is actually a graph, a picture of a graph. So I'm not going to draw the graph here because it is a textbook question. My editor, my friend, will kindly put up the graph somewhere in this region, and you guys will get to see it in front of you. I have it in front of me on a computer here. So essentially, there's a graph, and it's going to ask us to find some key points of it. So the first thing the graph will probably ask us to find, or we should find on there, is the vertex. I'm going to start writing over here, and I don't know where my friend will exactly put the graph, probably somewhere there, so I'm hopefully not messing around with his editing too much. But first thing we're going to look for is the vertex. Now the vertex is, if you remember from the previous 2 videos, the place where I can cut the graph in half and get the same thing on both of the sides. So it's basically a really special point. You'll know it when you see it, like on the graph. You probably already know what it is if you watched the previous 2 videos. It's essentially the maximum point or the minimum point. In this case, it is a maximum point because the graph opens downward, and it's a really specific point where I can cut it in half and get the same. Now, the graph does do a good job at kind of highlighting it for us. But if you look at the point, it's actually at 2, 4. So the vertex for this graph is at 2, 4. Because if you look at the point 2, 4, if I cut it in half right there, you'll see that I get the same thing on both sides. Thus, it's the vertex. And it's actually a maximum point in this case because it opens downward and it is the highest point available on this graph. Now, the next thing a question might want you to answer is the axis of symmetry. Axis of symmetry. Well, that's symmetry, I just kind of shorten it there if you don't mind, I'm kind of lazy that way. Okay, so the axis of symmetry, I kind of went over in the past video really lightly if you remember. If not, it's okay. The axis of symmetry is essentially the line that cuts the graph in half. So what would the equation of the graph be that cuts this graph in half? Or what would the equation of the line be that would cut the graph in half? So the way I remember it, the explanation I just gave was probably a little bit confusing. The way I remember it is the axis of symmetry is basically the x-coordinate of the vertex. So what's the x-coordinate of the vertex in this case? It's x equals 2, right? And that is my axis of symmetry. Because if I had a line that was x equals 2, right? That was just the line, x equals 2, it would cut this graph perfectly in half. So that's my axis of symmetry. Now, the question might also ask for the zeros, if you remember what those are. Let me just write that down real quick. Zeros are simple. Zeros are essentially where the graph touches the x-axis. So there's 2 points in this graph where the graph touches 2 points on the x-axis. So the first one is 0, 0, if you take a look at the graph itself. So my friend should have it there. And the other one is 4, 0. Again, the zeros are where the graph touches the x-axis. There's 2 points here, so those are the 2 points we put up here. So we have our zeros. I think it also wants the y-intercept in the question. Again, the graph might ask for a few more things, but these are essentially what any textbook will ask for if they give you a graph when you're getting introduced to quadratics. So the y-intercept is, again, where it touches the y-axis. So this one's a little bit special in the sense that the y-intercept is similar to one of the zeros, because where does it touch the y-axis? It touches it on 0, 0. So that's going to be my y-intercept. So essentially, this is all you'll be asked for an introductory quadratics section in a book. You will probably be given a graph like the one I just have up here, and you'll be asked to find these specific things. So again, it's not too hard. Vertex is the point where I can cut it in half. Axis of symmetry is the line itself, or the x-coordinate of the vertex. And the zeros are where it touches the x-axis. And the y-intercept is where it touches the y-axis. None of this is too difficult to do once you know what you're looking for again. It's just looking at a graph and finding specific points on it. Not too difficult at all. And I hope this was just a walkthrough. I'm sure some of you even solved it before I put this stuff up here. So that's one question I wanted to go over. I'm going to go over another question that you may see in a textbook. So let me just bring that question up right here if you don't mind. Yeah, so what if they gave us 2 points? Alright, so 2 points. So the 2 points I'm going to talk about here are 3, 2 and 9, 2. These 2 points are found on 2 sides of a parabola. So a parabola is the curve that we've been talking about of a parabola, right? And what is the axis of symmetry? So this is something you might see in the first little bit of a quadratics unit. Axis of symmetry. Again, you would write out symmetry, not just put a dot like that. There we go. So basically, we have 2 points. So imagine this graph here. Or I'm just going to draw this really quickly, just as a visual. Now, what if, so 3, 2 would be 3, 2, and the other one is 9, 2. So the graph could look anything along these lines, or it could even be downward. But these 2 points are on a parabola on the opposite ends. So what is the axis of symmetry, right? We're trying to find what x value would give us the axis of symmetry. So what is the line that cuts it in half? So it's not asking us for the position of the vertex or coordinates for that. I can go over how you do that as well, but this is what we need to know. So we have 2 points, and what is the axis of symmetry? So if you go back to grade 7, grade 8, if you remember how to find the midpoint of something or just the average, that's what we're going to do here. So we have 9 and 3, right? And we need to find the middle, or the point where I can cut this graph in half and get to the same thing. So if you remember the midpoint formula, so all I'm going to do is do 9 plus 3 divided by 2. So I'm sure some of you can mentally solve that very quickly. 9 plus 3 is 12, divided by 2 is 6. So guess what? The axis of symmetry is x equals 6. So if you see a question like this, it gives you 2 points and it wants you to find the axis of symmetry. All you have to do is take your 2 x values, don't do anything with the y's, take your 2 x's, add them together and divide by 2. Because essentially what you're trying to do is trying to find the middle. So 9 plus 3 divided by 2, 6. And I would write my final answer, x equals 6, is my axis of symmetry. And that's all there is to a question such as that. So there's one question, I'm just going to do one more, and then that should be it for this video. So this question I saw in a textbook, and I thought it's considered a thinking question. It's not too hard actually. Now that I showed you the previous one, this one should be very easy to tackle. So there's 2 points again, -1, 41, and 5, 41, I believe. Yes. Right? And the equation of this parabola is also given to us. It's y equals 4x squared minus 16x plus 21, right? So we have 2 points and we have the equation, and it wants us to find the vertex. What's the vertex, right? So you might be wondering, well, how do I go about this question? Well, first of all, the one thing you can find is the x-coordinate of the vertex. Because remember the previous question, we were trying to find the axis of symmetry, which is the x-coordinate of the vertex. So why don't we find the x-coordinate of the vertex first of all? Let's find the axis of symmetry. I think that's the best thing to go about doing. So again, you add your x's together and you divide by 2. So 5 plus minus 1 divided by 2. Be careful with the brackets and the adding. I feel like it trips a lot of people up. Tripped me up for sure when I was back there. I tripped up on a lot of things, but we don't need to mention that. But 5 minus 1 is 4, divided by 2 is 2. And there we go. So this is the x-coordinate. So x equals 2 is my axis of symmetry. But that's not what the question wants, is it? No. It actually wants the vertex itself. So to find the vertex, what I'm going to do is I'm going to plug in this value, because if x is 2, what is my y? That's all I need to find the vertex, right? Because for the vertex, let me just switch colors. So the vertex, here we go, vertex, right? We already know the x-coordinate. We figured that out, right? 5 plus minus 1, which is 4, divided by 2 is 2. We already know what the x-coordinate is, but what is the y-coordinate? We don't know. And how do we find a y if we have an x? Just plug in the 2. Exactly. So I'm gonna, y equals 4x squared minus 16x plus 21 is the question, right? So what I'm gonna do is I'm gonna plug in my 2. So y, or 4, so 2 squared, right? Plug it in with brackets always, minus 16, plug in the 2, plus 21. So 4 times 4, right? 2 squared is 4, minus 32, plus 21. Exactly. So 16 minus 32 plus 21. 16 minus 32 is negative 16. And negative 16 plus 21 is simply 21 minus 16 is 5. So my y-coordinate for that is 5. There we go. What is our vertex? Our vertex is 2, 5. And again, what did I do? All I did was I took the 2 points they gave us, found the axis of symmetry, which is the x-coordinate, and then I just plugged it into the function itself, or the equation. So, as you can see, these questions are not too hard, and there's a lot of resources on YouTube. You can check my videos, the previous ones. Once you get a good understanding of the basics, vertex, axis of symmetry, y-intercept, x-intercept, the zeros, it's not too hard to do these questions. And another question that you might see, I'm not going to do it right now, but some questions you might see are like, they'll give you a table of values, right? And they'll ask you to find out if it's quadratic or linear. And all you have to do in that case is find the second differences, right? Subtract the second y value from the first one and then do it again to get the second differences. So these questions are not particularly hard. All you have to do is just read the question properly and go over notes if you need to. And once you know what you're looking for, these questions are exceptionally easy to do. So hopefully that helped. In the next few videos, I'll go over the other forms of a quadratic equation and just some simple expanding binomials, things like that. And hopefully you guys are enjoying these videos and these are somewhat helpful.